well. Good morning to one and all present virtually for this faculty development program on nuances and trends in data science. I heartily welcome all the participants present here. May I request all the participants to switch on your videos so we can have a photo session. And this being the last day, I kindly request all the participants to switch on your videos. Thank you, participants.
To start up with the day, we have our guest, Ms. Bharti Duraiswamy, Senior Lecturer in AIMS University, Malaysia. She has a vast experience in lecturing degree students in the field of business, economics, and statistics. Previously, she holds an administrative post as a program coordinator, handling all finance program for the students. She has published papers on Islamic banking products, awareness and factors, customer perception on service quality of commercial banks, the impact of global financial crisis, of financial performance of conventional banks in Malaysia and others. We are honored to have you with us for the day, ma'am. Kindly take over the session and enlighten us with your thoughts. Ma'am, please.
Okay. Thank you, Dr. Sobana Suresh. Thank you for the introduction. And also, I would like to greet everyone. Very good morning to the director and also to all the professors and doctors here and our dear students. It's a great pleasure for me to have a session with all of you today. It's just that I'm not able to see all of you physically, and the physical interaction is not there. That's the sad part. However, I have met your senior students who walked into our campus before, and they were so good. They were very keen to ask questions. I would say most of them are very intelligent. So I'm meeting again all the students. They are juniors, so I'm happy to meet all of you actually. So without further ado, let me start my session. So please allow me to share screen. Thank you. Okay. Can I hear some feedback from students? Can you see the screen?
Yes, it's visible.
It's visible. Okay, thank you. Right. Okay. Okay, again, wish all of you good morning. Today, my topic is basic estimation and forecasting sales using time series regression analysis. Okay. Very first thing that I want to talk or introduce to all of you is about the estimation. Basic estimation means what? So you have heard estimation, prediction, forecasting. Okay, let us go through briefly. What does that mean? Estimation means it's the process of optimizing the true state of nature. Suppose we have 5 independent variables, and our target value is y. For example, let's say we want to forecast the demand.
Dr. Bharati,
yes?
Sorry for interrupting. Can you play the slideshow?
Okay, right. Thank you. Just give me. Okay, just give me a time. Hold on. Okay, what about now? Can see the slide?
It's
In the
still
slide.
in the same mode.
Yes, but here I can view as a slideshow. Let me see again.
Ma'am, in this window, in the status bar, can you see a book reading symbol? If you click on that, it'll,
But book reading.
yeah, in the status bar.
Status bar here, I can't see. Hold on. All right. Let me see here again.
Yeah.
What about now? Still not able.
No.
Oh, but here is already in a slide mode. Okay, let me see. Back to this book reading here.
அது வந்து கஷ்டம் அவங்களோட ஆல் டேப் கொடுத்து பண்ணுவாங்க இதுனா
What about now? Still not able to see in the slide mode?
yes, it's still the same.
Still is the same.
I think Mary, never mind. We will go ahead.
Go
Okay.
ahead. I'm very
Okay.
sorry. I'm not able. I do not know. Here it's already in the slideshow for me. I don't know why.
No, no
Okay.
issues. We can go ahead.
Go ahead. Thank you very much. Okay, thank you, doctor. Okay, so we're going to, let me start about the estimation. So estimation means is the process of optimizing the true state of nature, as what I just now shared to all of you. Let's say we are estimating about demand, and all of you know demand of any product, there will be so many factors contributing to it. That means why a consumer would like to buy a product. There will be so many factors actually can cost them. It could be price, it could be preferences, it could be their income or pocket money, and also it could be comparing with other products. This product is better. So many other factors. So these are the factors we call it as the independent variables, and how it can contribute to the dependent variable here is the demand. So estimation is after the occurrence of the event. Like for example, most of you would have done your statistics. So you would have done posterior probability. So you know that there would be some events would have been revealed in the form of scenario, and from there you would estimate the posterior probability. So that is basic estimation. So moving on, next is prediction. Prediction is a kind of estimation before the occurrence of the event. So you want to predict the future. You want to predict new data. So actually to make prediction on unseen data, we will fit a model on the training data set that learns an estimator, which is used to make prediction on new data. So here forecast will be used is time-based prediction. So it is more appropriate while dealing with time series data. So we would be looking at forecasting later. So, and before that, just regarding the prediction, you know that it is overall need not to be time-based only. It can be based on multiple causal factors that influence the target variable. So predicting the future as accurately as possible, given all the information available, including past data, historical data, and knowledge of any future events that might impact the forecast would be taken into consideration. So in summary, all forecasts are prediction, but not all predictions are forecasts. So we are coming to forecasting now. Forecasting is a common statistical task in business where it helps to inform decisions about the scheduling of production, transportation, and personnel, provides a guide for a long-term strategic planning. Usually in any industry, when they really want to have a strategic planning, so they would assign this task to some group of members there to do some forecasting and develop the strategy planning. So for them to forecast, they need to find out or identify who actually needs this forecast. That means who would benefit when you do this forecasting, who would benefit this, and you need to understand why they need it before you proceed to the process of forecasting. Okay, how the forecasts are actually used before embarking on extensive work in producing the forecast. After identifying who needs it and why they need it, then it is necessary for the forecasters to find or collect the data on which the forecast will be based. The data required for forecasting may already exist. We just need to collect all the relevant data and also timely data. And nowadays, I'm sure all of us know that a lot of data are recorded, and the forecaster's task is often to identify where and how the required data are stored. The data may include sales records of a company, historical demand for a product, or the unemployment rate, or the inflation rate for the geographic region. So all this data is... Yes?
We are able to see the second slide, that is the basic estimation.
Yes. Oh, you mean the slide is not moving?
No. We are able to see the second slide, the basic estimation slide.
Forecasting?
No, that we couldn't see.
Dr. Bharati ma'am, can
Yes.
you first play the slideshow and then share the screen with the slideshow presented?
Okay, yeah, let me see again. I try first.
Ma'am, you can use this entire screen sharing option.
Ma'am, instead of going for slideshow, maybe you can use the PowerPoint which you show to present so that we can see what you are discussing.
Oh, okay, all right. Let me try again. This share. Okay, let me try to move my... What about now? Can you see?
Yeah,
if I move?
now we can see. Yeah. With this itself, you can take them so that we can see.
Yeah. Thank you so much. I think, because when I put on the slide mode and I want to share, it stopped, the slideshow. Okay, I'm very sorry, students.
No problem, ma'am. Now it's visible.
Okay, right. Then just now
You can also try to click from current slide, ma'am. There's an option, right? The top.
Okay, now its title is forecasting. Can you all view?
Yes, ma'am.
Yes. Okay.
Yes,
okay, just now I already, explained about forecasting, and then I went on to, let me see. Prediction, forecasting. Okay, I was explaining about estimation, prediction, and forecasting. And just now I was telling about forecasting. Okay, usually it would be a kind of statistical task in business and so forth. I explained this. And then I said, before we embark into the process of forecasting, we need to identify who actually needs it and why they need it. We have to understand. And then regarding the data collection, once we know already who are the one that needed and why they needed, we need to proceed for data collection. And data collection, we know that most of the data are actually already there, and we need to know what are the data we needed, and we need to use that for the forecasting. Okay, moving on to next slide. A large part of a forecaster's time can be spent in locating and collecting the available data prior to developing suitable forecasting methods. For instance, predicting the trend in financial markets or electricity consumption, time is an important factor that must be considered in our models. Why I'm stressing on time? Because later we're going to see time series model. So for example, it would be interesting to forecast at what hour during the daytime is there going to be a peak consumption in electricity, such as to adjust the price or the production of electricity. Okay, this could be one example why we needed, a specific time to see that the consumption of electricity is high during what time. So this could be trigger someone to focus. This is one example. Okay, then I'm moving on to next slide now. All right. Yes, after learning about forecasting, we need to know about time series analysis. A time series analysis is very important because it's a series of data points ordered in time. And often time series, time is often the independent variable, and the goal is usually to make a forecast for the future. There are three aspects in time series that you need to know. One is about autocorrelated, seasonality, stationary. Okay, these three aspects we'll be going through later in one of the video. I will show it to you. Okay, here got some brief explanation on autocorrelation. Okay, informally, autocorrelation is the similarity between observation as a function of the time lag between them, which means we know that there would be some correlation between one time to another time. You can see some peak, for example, in 2019, you could see some peak values achieved regarding, let's say, electricity consumption in certain months. And then again, when you look at it in 2020, also same probably. But now it's not easy for us to compare 2019 and year 2020 because year 2020 and 2021 got a lot of changes happened due to the pandemic. So maybe when you want to see the similar peak that took place, the best is 2018, 19 or 17. We could see some pattern of the data, similar pattern of the data. Right. So next is seasonality. See, you know about seasons. Seasonality refers to the periodic fluctuation. For example, electricity consumption is high during the daytime. You're looking at the daytime. Daytime is high, then low at night. Okay, and then online sales would be increasing during festive season and usually end of the year. Okay, so you could see that kind of pattern in the data. And stationarity is another important characteristic of time series, where a time series is said to be stationary if its statistical properties do not change over time. And statistical properties here, they are referring to the mean, variance, where both will be constant at one particular period of time, and then the covariance is independent. Covariance is the calculation used for statistics, but if you look at the other model, it would be like correlations, comparing or analyzing two variables. Okay, this is one example of autocorrelation, where you could see this they plotted here, and dear students, can you all view this plot? Can you all view? Can I hear any feedback from?
Yes, ma'am, we can view.
Yes. Okay, good. Okay, so let me. All right. Okay. So this you could see when you look at this plot, you could see the beginning. In the beginning, the first value here is very high. Okay, and then if you look at it here, also very high. So the first value and somewhere here, we could say on the 24th, okay, 24th value have a high autocorrelation. Okay, a kind of the same pattern. And also you could see another one that is, I would say here somewhere 12th, it's written here 12th. And the other one is 36th observations are highly correlated. This means that we could say a similar value at every 24th unit of time. So it's you could see a pattern. Okay, could see a pattern. Okay, that is what we call autocorrelation. Well, I have few links also for you to know later. After we finish this session, I will be sharing some links where you can watch some short video clips on autocorrelation to understand better. Okay, this is for seasonality and also for stationary. This is the plot being used for seasonality and also for stationary, where there is a trend. Okay, the trend would be similar for some season, and this is about this particular record is just for a month, September 2017, 13, on 14, on 15, 16, and so forth. It's an example of seasonality. Okay, just a plot I'm showing. Okay, let me move on to next. Okay, yeah. The explanation for the graph just now. There is a clear daily seasonality. Every day you see a peak towards the evening. Okay, back to the graph again. Can you see, if you look at a day, 13 to 14, okay, it's very low and then going higher and then low, a bit lower, and then again high, and then higher, and then again drops. So this is what they're telling every evening, every day, in a day, every evening, there will be a peak, okay, evening. Because this 13, day 13, and then day 14, 24 hours in between, 24 hours. Stationarity. Looking again at the same plot, we see that the process above is stationary. The mean and variance do not vary over time. Often stock prices are not a stationary process. This one, for the one just now we saw, this is stationary. Okay, but they're saying not for all, you will have stationary process. Okay, there might be some growing trend and the volatility might increase over time. Variance might be changing. So ideally, we want to have a stationary time series for modeling, ideally, but sometimes it's not possible. So we need to adjust our data. Of course, not all of them are stationary, but we can make different transformation to make them stationary. That's one example. All right, this is about stationary. They say, you may notice in the title of the plot just now, this title, you can see here, Dickey Fuller. That's the process. Okay, class, students, are you all with me? I'm now the title in the first sentence, how to test if a process is stationary. Are you all with me? Yes?
Yes, ma'am.
Okay, thank you. So you may have noticed in the title just now, title of the plot above, Dickey Fuller. Okay, this is the statistical test that we run to determine if a time series is stationary or not. That is one of it for us to test whether the data set is stationary or not. But another one is, without going into technicalities of the Dickey Fuller test, we can also use null. We can go our normal way of statistical test, hypothesis. Can you test the hypothesis? null and alternative hypothesis, where we can see if the p-value greater than 0 and the process is not stationary. If or otherwise, the null hypothesis is rejected and the process is considered to be stationary. This is statistically, or you can use Dickey-Fuller test. How to use it, we can always take this tutorial YouTube. You can find. It's not so hard. Okay, next is, I'm moving on to next slide. Okay, this is one example where it shows this process is not stationary. The process below is not stationary because the mean is not constant through time. It's, it is not similar to the plot which I shared just now. All right. Okay, you can see some trend, whereas here it's not easy. Okay, too many cycles in a very short period of time. Okay, so one of the most important analyses for prediction and also for time series is regression analysis. I wouldn't know whether have you heard this or you have studied in your courses before, regression analysis. Can I hear feedback from 1 or 2 students? Have you done regression analysis before? Anyone? Any volunteer? No response? Can I?
Dr. Bharti, you are addressing to faculty group as well as research scholars group. A few students are there in this group.
Okay, right. Thank you, Doctor.
Right.
Okay. So regression analysis, I think you all know, it's an analysis that used to estimate the parameters. Okay, and to use regression analysis, we need to identify the variables are falling in dependent or independent variables. So dependent variables, variable whose variation to be explained. That means we are looking at what are the variables actually can explain the change in this variable. For example, sales. When you want to analyze about sales, one of the most important component or factor that really can influence the sales is the price. Okay, so the explanatory variables is price is the one explain the change in the sales. Okay, example. So sales, the sales values, total sales in every month would be here under dependent variable column, and the explanatory variables, or rather we would say independent variables, are the one that amounts of the price per unit, selling price per unit. Okay, other than that, of course, got so many other factors can contribute to sales. It could be advertisement. It could be what they call on the supplier's viewpoint on how to have aggressive promotions, and also can get a good price from the vendors. So many factors actually. But we look at the simple one first. So in order to get the picture of it, so picture of this regression. So we look at the simple. So we're going to actually look at simple linear regression. So now I'm with this slide, class. Please go along with me by looking at the slide, and each time I'm mentioning the title as well, simple linear regression. So simple linear regression, the parameters or the equation, we call it function, y equals to a plus bx, where you all know this is the one that I always say that from beginning, dependent variables, and this dependent variables would be influenced, or the changes, it's all, it rise or decrease it depending on this variable. So this is the independent variable. Okay, so this is how we write the linear regression, simple linear regression. That's why we have only one. If you have multiple linear regression, then you will have more. Okay, intercept parameter. What does this mean? Look at this function here. Okay, the regressions function. A is alone. This value has no connection with the independent variable. So this is what we call intercept parameter. If you look at the graph, later I'll show it to you, the graph, you will plot the line, the line will cross the y-axis. In a graph, we have y and x-axis, so it will cross the y-axis. So this is what we call intercept parameter, and it gives value of y where regression line crosses. Here it says crosses y-axis. And this one, B, is known as slope parameter. Slope, okay, gives the change in y associated with a 1 unit change in the x. Let's say B is 10, okay, assuming B is 10. So 1 unit change in the x, you can see there is a change in y by 10 units because, here got 10. Okay, if it is 5, then 1 unit change in x, you could see the change in y by 5 units. Okay, so the formula is this: change in y over change in x. All right. Okay, now I'm moving on to next slide. Okay, this is talking about only one independent variable here in this case. Okay, and the relationship between x and y is described by a linear function. Okay, this is a linear function because there's no power of 2 or 3 and so on. It's a linear function. Okay, that means there will be a straight line. Relationship between x and y is described by a linear function. There will be a line, straight line. Changes in y are assumed to be related to changes in x. Okay, this is why they're saying again, because of the simple linear regression, there will be only one independent variable and their relationship is linear. Okay, and y, of course, assumed, changed happened due to x. Okay, next, we are looking at the relationships, correlations. Okay, if you look at the regression, they call it these correlations. What does correlation means? Correlation means we are analyzing the relationship between two variables, variable x and variable y. So when you look at this, this is actually linear relationship and this is curvilinear, but they have a relationship. Why am I saying they have a relationship or a pattern? You can see, for example, if x rise, y also rise. Okay, for example, you pick one point from here, y also rising. Okay, so both variables are moving in the same direction. So this is what we call positive linear relationship or correlation also when you are analyzing the variables of y and x. For example, this is the total sales and let's say this is the price. Okay, all right. So your sales would increase when price rise. Okay, so positive. Okay, this one also having a relationship, the bottom one. Okay, this one is not, both variables are not moving in the same direction. They are moving in the opposite direction. Why am I saying that? Because you look at this x. Okay, when you increase your x, okay, as you reach here, what happened to your y? Your y would be somewhere here. Okay, all right. So let's say you are here. Okay, your y would be very high. So when your x is low, your y is high. But when you increase your x, you need to decrease your y. So both are moving, both variables are moving in an opposite direction. So they have a negative correlations. Okay, this is the same, but then it's just that curvilinear relationship. Okay, the pattern is different. However, I also can show you a strong and weak relationship. Okay, look at this part. This part, both are really strong, even though this is positive direction and this is negative direction, because you could see the data set falling very close to the regression line. Okay, the prediction line. Whereas this one, the data sets are actually further, okay, going further from the line, prediction line, which means you can't actually justify later at the end of the study or forecasting that the relationship is strong. Okay, it's indicating weak relationships. Okay, and then there would be another situation where you all can see no relationships, right? No relationship like this. Okay, if like this, the pattern is like this when you do the scatter plot and then you found. So no relationship between X and Y. So we forecaster or the predictor always want to see some relationships. That's why we engage in doing research or forecasting, by collecting the right data. All right. Okay, talking about this linear regression equation, here statistically they explain what is this known, and this is, can you see here? Okay, there's a symbol which means estimated. Okay, estimated or predicted. Okay, Y value for observation. And this is also because of the symbol, estimate of the regression intercept, and this is estimate of the regression slope. And this is just because all are actually estimation, this is, we call it as a value of X for observation. Okay, you know that this Y, okay, depending on this X. So, but the moment you have this symbol, meaning you are actually estimating. And later we're going to compare the estimation with the observed value. Okay, so one of the under the regression that we would use for the time series is OLS, ordinary least squares, very popular as well. OLS is a method to quantify the evaluation of the different regression lines. And in this, choose the regression lines that minimizes the sum of the squares. That means the comparison between observed and predicted values, not so much gap. So the differences between, observed dependent variable and the predicted dependent variables, smaller, minimize that. Okay, so OLS would be the best method to quantify this evaluation. Okay, this is statistically calculation, the formula for this, the least square method. Okay, here I have one example, simple linear regression example. If you see this, it says a real estate agent wishes to examine the relationship between the selling price of a home and its size, which is measured in square feet. That means this agent is claiming the selling price of a house is actually dependent on the size. Okay, size which is measured in the square feet. Right. So we have a random sample of 10 houses, random sample, and dependent variable, which is obviously is the price of the house, because here he already claims he wants to see whether the price of the house can rise or can fall depending on the square feet of the house. So square feet would be the independent variable. So let's see next. Okay, the data set for this, for house price and square feet. Okay, so let's pick one. For example, okay, this is so high. The price of the house is $405,000. Here it says $1,000. 405, and the size is 2350. But this size is even higher. Okay, depending on the location. I mean, the unit is actually located at the site or in the middle, depending on that as well. But not so much difference. But this is the highest price. And then we see the lowest price, I think, to 199. And the square feet is 1,100. Okay, this is the pattern, the data that collected, and we are just seeing the pattern. Next, let's look at the relationship by having the scatter plot. You could see the data, is fall like this. Okay, there is some relationship between both variables. Okay, let's say we input this in Excel. All right. Students, you can use Excel to get the output of regression. You can regress. How do you do that? Okay, very simple. If you have your Excel in your laptop, you can just you click at data, and then Once you click, you will have your data analysis on your right hand side. One icon will appear. Click at that, you will pick regression. That's all. Okay, you click, you will have this will pop up. The moment this pop up, your work is just to verify what is your y and what is your x. And you know that all of you already went through, you know very well y is the independent variable. So you need to just range it, and you put your cursor here, range it, you will put, you have that range for y, and for x, you will range this and you will, get this. Press OK, you will get your output, and your output will be like this. Okay, you will have your linear regression output using Excel. Obviously, some students might be thinking, can use SPSS or can use other statistical packages, software. Yes, you can. Okay, you can. But this is the easiest because you already have spreadsheet, you have your Excel, so you can get it done easily. You see, the Excel is making our life so easy, computed everything for you. All right. And the very important one you need to know, if you do manual calculation, would be very late. All right. Not easy for regression. You need to use some statistical package. So we are using Excel and we got this output. Please look at the, not first, second, look at the third boxes. I would say the third one or third row. Okay. You could see here, they stated here intercept and square feet. Intercept, right? This is, if you write y equals to a plus bx, this is square feet, this is b, this is a, and this is y, which is house price. So look at this. This is your intercept, which is here already. So you can no need to write a, you can straight place the figure now. You are writing the regression equation here. Okay, by stating what is the intercept and what is the slope. The slope is 0.10977. Okay. Okay, right. So this is important. So you already got your equation. And other than this, you also can check your significant. Okay, your significant, whether it's significant or not. It should be lower than 0.05. Yes, it is significant. And if you look at your p-value, which is 0.05 for your square feet, yes, it is lower. All right, so it is significant. Okay, and then another important one is you can see is R square. Okay, I have some slides on R square also. Okay, R square is here stating 58%. That means it's telling that 58% of this factor, influencing the house price. That means remaining how many? Okay, I would say 42% could be other variables which we have not included in our regression. Okay, could be other variables. So these variables is actually influencing, okay, house price 58%. So it's very important. Okay, hope you can follow through. And this is the linear regression graphical representations where you have the prediction line and the data. Okay, plotted, scatter plot and prediction line now. Where this is the intercept where it crossed the y-axis, and this is the slope. Okay, if you pick and calculate the slope. Okay, that's how you can obtain this in your regression. So then you will write the actual equation and you'll explain what does this mean and what does this mean. This is for writing the report for those who are doing research. Okay. Okay, next. Okay, this one is the explaining about the slope, where it says house cannot have a square footage of 0. Okay, so has no practical application, which means there would be some value for this. Like, for example, when consumption, okay, for consumption also similar. that would not be zero here, surely got some value, which means even though we don't have to, I mean, we can't afford to buy, we still have to consume. Okay, so therefore they said practically there would be some, a value. Okay, this is about the slope explanation, where just now I mentioned 0.10977 tells us that mean value, okay, of a house increases. Okay, so if any value of this increases by 0.10977 here, 1000, multiply with 1000, don't forget, because everything in thousands. Okay, so next, I think this is about the variation measure, where this one they call it as a SSR, sum of squares. This is the error of sum of squares. Sum up, you get the total. This one is a statistical application for you to know that, which it says that, this is the mean of y, and this is the observed value, and this is the predicting value. So the difference is what we call error sum of squares, SSE. Okay. Okay, this is about the R square just now, which I already explained to you, the explanation. Okay, so R square, it shows that here 58.08% of the variation in house prices is explained by the variation in square feet. Okay, so the same output just now, which I was explaining to you, and here, or you can do the calculation manually if, let's say, this part is not given. All right, for statistics students, they can calculate once they have this value, and they can see exactly same. Okay, so residual analysis, where the difference, okay, you can see the difference between its observed and predicted value. Okay, and this one, check the what they call assumption of regression by examining the residuals, that all this thing must be, fulfilled for linearity assumption, independence assumption, all those assumptions need to be considered. This is for the residual analysis. Okay, the residual analysis for normality, normally using a normal probability plot, normal errors will approximately display in a straight line. Okay, for time series, autocorrelation is very important, and one of the tests that usually used is Durbin-Watson statistic. Okay, when data are collected over time to detect if autocorrelation is present. Okay, so autocorrelation is, you all know that is a serial, it's known as a serial correlation, refers to the degree of correlation of the same variables between two successive time intervals. All right. Okay, so Durbin-Watson statistic is the one that commonly used for autocorrelation lah. Let me move on to next. Okay, this is example. Autocorrelation is correlation of the errors over time. Okay, you can see the pattern. Residual shows a cyclic pattern, not random. Cyclical patterns are sign of positive correlation. Okay, so this is the one that I said that is a link for you to go through the video to understand how actually, this you can look at this autocorrelation by really plotting the graph, using the data, and then we analyze. Other than simple linear regression, usually for your research, you would go for multiple regression model, which means you may not have only one independent variable. You may have more variables, more independent variables, x1, x2, x3, and some students or some researchers will have about 10 variables, okay, to process it. Okay, this is an example of multiple linear regression where they have, more independent variables. You can see this is the sales of pi, and then this is the price and advertising, 2 variables. So you will have, you see, B1, B2. And when you have you process that or you input into the Excel and you solve it, you get the output like this. Okay, the output where you could see the third part, the intercept, then you have two independent variables. If you have more, you have more. And also you can check here the observation 15, how that observation, the total number of your sample size that you collected, 15. Okay, so here. And this is the equation, regression equation that you will pick this and you will write it. Okay, so this is the intercept and this is the independent variables. This is a B1 slope. Okay. All right. Okay, this one you will, yeah, you know the definition which we already know. I told you that. For example, let's say they give you some values for price and some value for advertising. You substitute, you can find out what is the sales. So that's the best part, you know, you can find out what would be the future sales if you target, you know, you come up with the selling price, you found out this is the selling price would be, and this is the advertising, okay, would be, and then you substitute and you check your total sales would be how much. Okay, that's the interesting part for sales people, okay, or sales department to know. Okay, now we are coming to the end, that is time series data in regression. Okay, time series data in regression, you all know that it's very important because we need to take into consideration the time factor. So regression analysis to be performed and data has to be stationary, or the equation has to be rewritten in such a form that indicates a relationship among stationary variables. And this also you just now went through. All right, so let me show you. Okay, I have no idea whether I can play the video and can share or not. Let me try. Okay, I would like to show part 1 to you, how to, there's other links, can y'all snapshot, you know, all these links, later you can go through. I want to show part 1, how to actually, you know, you can get into this time series. Okay, okay, let me stop sharing first. Let me try and see whether I can share with you the video. Just give me a minute.
Hi guys, I'm going to show you.
Hold on, yeah. Can y'all view my this one? The
How to deal with time series
Yes, sir. Yes, ma'am. We can view it.
oh, okay, right.
data in Excel. So we're going to jump right in. Hi guys, I'm going to show you how to deal with time series data in Excel. So we're going to jump right into an example. This is the quarterly sales data for car sales. Okay, so and it's quarterly because the sales, which is what we're measuring here, is recorded once every quarter. So we also have this column here, which is the year. So in year 1, quarter 1, sales were 4.8, and that's measured in thousands, so that means 4,800 units. In year 1, quarter 2, sales were 4.1, or 4,100. And finally, so we understand this data clearly, in year 4, quarter 3, for example, sales were 1,000 units, recorded as 8.0. Okay? So this right here comprises the historical time series data. Okay? And what we're measuring here specifically is sales. And the goal of all this is that we want to be able to understand how sales moves through time and then be able to project that or extrapolate that into the future, into perhaps year 5. Okay? So by the end of this video, we should be able to make predictions for these blank cells over here, quarters 1, 2, 3, and 4. Okay? So let's approach this in a step-by-step fashion. So there's going to be a lot of columns we're going to have to create, plots, and little steps along the way. But the great thing is you can always pause the video and go back and see what I did. Okay? So step 1 is to just visualize the data. So for this step, we're just going to create a line chart with markers. Okay? So let's do that. We go to Insert.
In this video, I'm going to show you why getting my head shaved is actually the key for you.
Line, and we'll choose line with markers. Okay, and Excel sometimes just goes ahead and suggests some things, but we can clear that out by going to Design, Select Data, remove everything. So we start with a blank slate. Now we're going to add, the name of the series is Sales. Okay, that's the data that we want to understand and be able to eventually predict. Okay, and here's the actual historical data. Hit OK, and already you could see that there's this really cool kind of up and down cycling going on here. Okay, we're going to talk about that in a second. But before we finish this plot, let's replace this horizontal axis with the actual years and quarters, so we can always go to exact time point that we're interested in. For example, if we want to look at year 3, quarter 2, right now we would have to do a little bit too much thinking to find that. Okay, so let's fix that axis. We go Edit, and we can highlight both these. So if you have 2 columns like this that are connected that tell you the time, you can highlight both of them. Okay, hit OK. Okay, and we're done. Maybe we give this a title, Time Series. Plot of car sales. Okay, that's a decent name for this. Okay, let's make that a little smaller. Okay, and the legend's going to be useful because, as you're going to see, we're going to keep adding plots on top of this one. Okay, series on top of this one. Right, so let's move this to the side. So that's step 1. Now we take a look at this, what we've created here. And let me make it a little bigger actually so that we can start understanding what we're looking at. We can clearly see that there's this pattern that kind of repeats itself more or less every year, right? So within year 1, which is between these 2 lines I'm drawing, there's this kind of dip and then climax. Then in year 2, there starts a dip and then a climax. Again, a dip, year 3, climax, dip, climax. There seems to be a cycle, or what we call seasonality, because this cycle occurs within 1 year, right? This down then up cycle repeats itself once a year. We call this seasonality. Okay, so that's one component that we can visualize from this plot. The other thing we can visualize is that this, if you take a more zoomed out kind of perspective, a fuzzy perspective. Take off your glasses, if you will. You'll notice, besides this up and down movement that we just talked about, the overall direction of this plot is somewhat increasing, right? Can be summarized maybe with this very simple straight line. Okay, so that's what we call the trend component. Okay, so far we talked about the seasonal component, which you can see, the trend component, which you can also see with a slightly different perspective, and then the final component in the model that we're using here is going to be the irregular component, which means the day-to-day or quarter-to-quarter variation that exists, that's kind of beyond explanation and doesn't follow any pattern. The irregular aspect, they call it, sometimes they call it the random aspect, okay? And that's always present in data, no matter whether it's time series data or not. Okay, so we have to account for variability, because nothing follows, in the real world, nothing follows an exact kind of perfect, up and down, predictable pattern. Even though there is a discernible pattern, there's going to be slight variations from time period to time period. Okay, so those are three components that we're going to have to deal with in the time series analysis. Okay, so now let's put this chart aside for now and go to our second step. Okay, so our next step in this analysis is to create a column, which is just a kind of a time code column. Okay, so let's insert that in front of the time series data, and we'll just call this T. Okay, and let's just center this, and all it's going to be is a time code. So the first period that we have data on, which is year 1, quarter 1, we'll call 1, and then we'll just increment this up, holding down the control button, all the way to the last period that we have data for. So we have in total 16 periods. Okay? We're going to come back to this variable quite a bit. It's important to create it further on. All right? The next step is to smooth out. This is where we actually are getting into the analysis and manipulation of the time series data. So as you all agree, there's this pattern going on. This pattern that I drew in red is the seasonality component of the time series data. And it also includes the irregularity. Okay, so in this step, we want to smooth, okay, and I'm going to put this word smooth as our O's in quotes, because what we're attempting to do in this step, which is going to be in this column, is to kind of put an iron on this data, if you will, to kind of flatten out all the up and down and try to smooth out the line, okay? To do this, one technique, and the technique we're going to use here, is to take a moving average, okay? So, and because our cycle lasts 4 periods, because as we discussed, it dips and then climaxes, dips and climaxes, and then climaxes once every year. So one cycle is 4 periods, 4 quarters. Right? So we can take a moving average of 4 periods. Okay? And the way we do that is you can go down to about the 3rd row, and you're just going to use the average function here. And you're going to average, starting with the top 2, with the top values, you're going to go down and average the first 4 numbers, okay, from your time series. Okay? Then you can drag this down, and you can drag it down all the way, and you'll see that we're going to have to delete some of these values at the end. Basically, we want to make sure that each one of these calculations includes 4 numbers, okay? So, obviously the first one is good. The next one drops. You see? It dropped to the next four numbers. And this pattern continues all the way down. And if we go to the last one, we'll see that the last one doesn't catch four numbers because of this blank cell. So we don't want this. Okay, so let's just delete this one. The one right above it does catch four numbers, so it's perfect.
Can you all view the video, dear students? Can you hear me?
Yes, ma'am. Yes,
Can
ma'am.
you? Can, huh? Okay, thank you.
Yes, ma'am.
Okay, so this is the moving average of 4 periods. All right? Now, the next step is connected to this step. We can, because we're taking a moving average of an even number of periods, we have this kind of problem where this 5.4 actually represents the center between these four numbers, right? Right, because it averaged these four numbers. And so it should actually be written over here, 5.4, which is between the two rows, right? And then this pattern continues on and on for the next four, right? So this 5.6 should actually be written in between these two rows because it represents, 5.6 represents the center of the next four numbers. Okay? So these numbers that we have here are not centered because they fall in between the numbers that they're averaging. And that's always going to happen when you average an even number of numbers, okay, in a time series data. So what we have to do is this next step, which is centering it, and it's called centered moving average. Okay? So if you had done an odd number here, you wouldn't have to do this extra step that we're about to do because you would already have a centered moving average. Okay, CMA, centered moving average. So the idea here is that if we average this number and this number, then we're going to end up back into the center, back into a row that we can associate with a value. Okay, so let me erase these lines and draw it one more time for the first one. What we did in MA4 is where we averaged these four numbers. So the average of these four numbers represents the center of these four. So it should be placed in the middle of this row. In other words, it doesn't fall into this cell or into this cell. And so we had to kind of put it somewhere because Excel doesn't let us go in between cells. So, but really it's over here. And then the 5.6 is the average of the next four numbers, these four, and it falls in between these two rows. Okay? I'm doing this just for the first two so that you can understand the concept of centering. So the idea is these two fall into no man's land. I can't connect 5.4 to 2 or to 3 because it falls in between 2 and 3, right? And 5.6 falls in between 3 and 4. So I have to get these back into a row so I can connect them back to these numbers. So the way you do that is you average these two, and the center of two off-centers falls back into the center. And we'll be back into a proper row, and this number will be associated with the row year 1, quarter 3, or time code 3. Okay, so that's the idea behind centering. So the way to do that equals average again, and this time you're just going to average the two numbers. Okay, and then you can drag this down. Okay. And you'll be able to drag it down all the way, and then just test whether two numbers were average. This one obviously has a blank in it, so we don't want this. Okay, so the one right above, perfect. So in effect, we've created a centered moving average in this step. Okay, and now these numbers are useful for us because they're connected properly to our row. Okay, so now I can plot this stuff, the centered moving average, right on top of this plot. Okay, so this step, remember, was the point of these two columns was to smooth the time series data, to get rid of the seasonality and irregularity components. Okay, so let's plot this. So in order to plot this, let's pull the plot back up. Let's click Design, select Data, Add, and the name is going to be Centered Moving Average. The values are going to be these values, right? But be careful, if you just highlight these numbers, Excel's going to start 5.5 here, okay, at year 1, quarter 1. When we know that 5.5, we did all that work, is connected to year 1, quarter 3. In other words, we don't have any centered moving average numbers for year 1, quarter 1, and year 1, quarter 2. Okay, so you should highlight the blanks. Likewise, you should highlight the last two blanks because we want Excel to plot it in the right place. So we don't have values for year 4, quarter 3, and year 4, quarter 4. So why don't we tell Excel that? Okay. Hit OK. Hit OK. And as you can see, it plots the smooth out centered moving average of 4 periods right on top of the original time series data, which is in blue. Okay, so at this point, I'm going to stop this video, and I'm going to call this video A, and I'm going to create video B so that you...
Okay, I think this is the part 1, how they started. And let me stop this. Okay, and
we can continue with this amount.
okay, and then let me unshare this. Hold on, yeah. Okay, so the other part 2 and 3 which I shared just now, you all can view that. Okay, then part 2, part 3 is here. You all can continue. And part 3, you will see one more cycle for year 5. Okay, so that is about time series using Excel. Okay, and then there's a few more. This is also about overall how to plot time series, and this is auto correlation. Okay, so with this, I think I would end my presentation here, and I open for Q&A. Any question?
Ma'am.
Yes.
Apart from sales data, where I can apply time series, ma'am?
You Geeta Varadarajan, is it? Okay. Time series can be applied for all the things that they want to predict and also involve time. For example, we can pick one industry. Let's say the industry want to predict about their employment, okay, employment, or could be the production level. So they could compare from let's say a few years back and until now. That is for time series. But if let's say they only want to compare overall the production, okay, production level for so many plants for one particular year, then they will use cross-sectional analysis, not time series, cross-sectional. But when they decided to compare from one period to another period, or could be from 1 week to another week, then it's already, they are using time series. It could be anything, not necessary for sales. Can use for demand, can also use for production, can use for even for calculation of gross demand, GDP, inflation, unemployment rate, for so many. Actually. So it's very useful for so many areas. And they can
chat window lo questions irukka parunga.
Chat la. Chat with everyone. Yeah. Okay. In the chat box, okay, I would share the YouTube link, and then okay. So far, only few questions. Okay, that's everybody greeted here. Good morning to me. And then there is a question from, not really question. The person said, kindly share. Bharani Rani B, kindly share the YouTube links in the chat box. Okay, right. I would share it now. Thank you. Thank you, Bharani Rani. Okay, this can you all view in the chat box? I already shared the link. Okay, and I also shared another 2 more. Okay, these are the link, YouTube link. Kindly watch this. It would be very interesting because just now I'm sure you all noticed that to come up with the overall or to develop the time series data or time series plot, actually the person has shown how to perform moving average, 2 important calculation, moving average and exponential smoothing. By applying these 2, at last, the third one, part 3, if you see in the chat box, I have shared the part 3 link. They will develop 1 more cycle for the following year. It is actually prediction, but the prediction by using these 2 methods, that is what I said, moving average and exponential smoothing, it's very, very close to the accurate observation. Okay, so kindly watch that. Don't forget. I encourage all of you to watch so that you got the picture of overall time series. Okay. Thank you, ma'am. Thank you to all the professors, doctors, and directors for staying with me until now. Thank you so much.
Thank you, ma'am. It was a wonderful session. May I now request Dr. B. Sudhakar, Director, MBA Department, to sum up on the 5-day events of our International Faculty Development Program.
Very good afternoon to all. I think another few minutes. The Department of Information Technology and the Postgraduate Research Department of Management, MBA, has nuances and trends in data sciences. It was possible for us to organize this program by the support of 3 different universities from Malaysia: the AIMS University, the Asia Pacific University, and Multimedia University. We are thankful to all the heads of these universities and the members of various departments of these universities who are kind enough to support our initiative to make this faculty development program possible. On day 1, we had Dr. Radhimala, the senior lecturer from Faculty of Management, Multimedia University, where she shared her expertise on business data analytics. Following her, Dr. Bhuma, a data scientist and business analyst lecturer from Asia Pacific University, shared her expertise on machine learning and artificial intelligence, the trends in data sciences. The third day, we witnessed Dr. Shankar Dorekannan, the research coordinator from School of Engineering, Asia Pacific University, sharing his expertise on 6G sustainability towards 2030. On 4th day, yesterday, we had Professor Parthiban Vardarajan, lecturer from Faculty of Business and Management, AIMS University, where he shared his expertise on bioinformatics and data sciences. And today we have Professor Bharati Duraiswamy, senior lecturer, Faculty of Business and Management, AIMS University, on application of regression analysis and autocorrelation in data sciences. So we had a wide spectrum of topics which were discussed over the period of 5 days, which would have given a basic insight to the various trends which are happening in data sciences. This would be an eye-opener for people who are looking at specializing in data science and getting the nuances which are needed for them to really think of further study. So at this point of time, on behalf of the Department of Information Technology and the MBA Department of Hindustan College of Arts and Science, and on behalf of the management as well as the principal and the heads of the department, I thank all the universities which have helped us in organizing this faculty development program. I personally thank all the resource persons who have been kind enough to be with us and sharing their valuable expertise so that we'll be really looking at how to go about from this point of time. We are looking forward continuous association with all these universities and the faculty members. Thank you all participants for being with us. Thank you very much. Over to you, Marrynal.
Thank you, sir. The smallest act of kindness is worth more than the grandest intention. May I now request Dr. V. Saravanan, Head Department of IT Department, to render his vote of thanks. Sir, the mic is muted.
Thank you, Marrynal ma'am. Good afternoon to everyone here. I'm so grateful presenting the vote of thanks. Today's session, basic estimation for forecasting sales using time series regression analysis, presented Ms. Bharati Duraiswamy, was really fascinating as it is the current trend topic. Thank you, Bharati ma'am. Also, I would like to thank all the members who had presented the session for all these 5 days faculty development program. It was really beneficial for all the faculty members and research scholars. Thank you all for that. Now, I would like to thank our Hindustan management for permitting us to conduct this 5 days faculty development program. Also, I would like to thank our principal sir, Dr. A. Ponnusamy, and our MBA director, Dr. Sudhakar sir. I would like to special thank to our faculty development program coordinators, Dr. Marrynal, Mrs. Arulmali, and Dr. Shobana, and for all the participants to our beloved staff members. Thank you. Thank you all.
Thank you, sir.
Professor Bharati, thank you very much for your time.
Thank you. Thank you,
Yeah.
Director. Thank you so much.
Thank you.
Thank you to all the organizing team. Thank you for everyone. And sorry for the shortcomings. Just now, I was not able to set in the slide mode.
That's
plus-
not an issue, ma'am. Not at all.
Technology sometimes doesn't help us.
because here we use Zoom link and we are so used to it, very familiar with how
Right.
to use the Zoom. Okay.
Yeah, there are some issues with Google, right?
Yeah.
Thank
Thank you
so
very much.
much.
Thank you.
Thank you, ma'am.